Hello, everybody. This is going to be your geo tour for plate tectonics using your plus or minus chart, which you've found already on Google Classroom. And here we go. I'm going to try and make this as quick as possible. I would recommend speeding you up to 1.25 or 1.5. The first one on your list, okay, is the Alpine Fault in New Zealand, which goes through the Southern Alps, and it is a transform boundary, okay? It has to be a transform boundary in order for a trench in the north and the south to be working in the opposite way. So we can see that we have ocean versus ocean convergence on either side of New Zealand. And the Pacific plate subducts underneath the Australian plate in the north, and it's the reverse in the south. In order for that to happen, it has to transform or slide past each other in between those two locations. Alpine Fault transformed through South Island of New Zealand. Formation of the Rocky Mountains, okay? Long story, try to keep it as short as possible, but it is historic. It's no longer happening, but it was made by ocean versus continent convergence beginning over 30 million years ago. You can see there used to be a plate out there called the Farallon Plate, and as it gradually completely subducted underneath North America, and eventually the Pacific plate started to scrape across the western coast, or most of the western coast of North America. That helped to create the Rocky Mountains, okay? So we can see that they are so far inland because of a very shallow subduction zone. And then once that plate completely subducted, it then brings us to our next location, which is not an active boundary right now, but it is divergence or continental rifting. Because that plate, the Farallon plate, which is no longer with us, it is continuing to become part of the upper mantle. That allows for rising asthenosphere, convection meeting on its hot sides, and pulling apart, which is apart, okay, which is creating a basin range region throughout some of the southwest and western United States, like out in Nevada, okay? That is divergence continental rifting. Maybe that will become a new boundary someday. Here we have the Lesser Antilles, ocean versus ocean convergence. You have your classic trench and volcanic island arc. This is just north of South America. And this is the Lesser Antilles Trench, where we have the North American plate subducting beneath the less dense Caribbean plate, giving us that volcanic, a very nice tropical islands, as long as there's not a hurricane or a very explosive volcano. The Aleutian Islands, okay, now they are islands. These ones a little tricky. If you said ocean versus ocean, I'd still give you the credit. But if you do a little bit more investigating, you'll see that it's actually continental crust, or most of it is, and those islands are rising up through continental crust that just happens to be covered by water. So this is a continental shelf here. So this is your ocean versus continent convergence. The Pacific plate is more dense and it subducts in front of the North American plate. The Peru-Chile Trench and the Andes, I believe that's also on your list, or it might be combined. That is probably the best example of ocean versus continent convergence. It's considered what we call an active continental margin. So that tells you that there's a trench off the coast, the Peru-Chile Trench, just off the coast of Ecuador, Colombia, Peru, and Chile. So big earthquakes here. The Nazca plate subducts with oceanic crust under the South American lesser dense or less dense plate. Probably the most famous divergence area in the world, next to the Mid-Atlantic Ridge, is the continental rifting of the East African Rift Valley. So up here we have the Red Sea, and here we have the Aden Sea, and those have ridges in them. They are working like a zipper, okay, and rifting through out Eastern Africa. In this part of East Africa, you can already see it getting lower. We have this chain of lakes forming. Good amount of earthquakes here, fault block mountains. That is continental rifting, weakening of the crust due to rising asthenosphere. The next one, Kamchatka, which is just fun to say. Kamchatka, that's a decent chunk of continental crust, that peninsula. It kind of hangs down here off of eastern Russia. And we have the Pacific plate, okay, a very famous large oceanic plate subducting into the Kuril-Kamchatka Trench, creating a massive amount of volcanoes, probably the most densely populated volcanic region of the world, or at least one of the most, if not the most. And that is, like I said, ocean versus continent convergence. Next up, another ocean versus continent convergence on the other side of the pond, or Pacific Ocean, I should say. And that here we have the Cascadia Trench. We have this really small plate called the Juan de Fuca, named after a famous explorer, that is creating crust, oceanic crust, sending it not too far away and under the North American plate. So all of these volcanic mountains that we have throughout Northern California, Oregon, Washington, and a little bit of British Columbia, those are all being created by ocean versus continent convergence, subduction in the Cascadia Trench. Next up, another very good, very famous example of ocean versus ocean convergence is the Marianas Islands. Some of you might have heard of the Mariana Trench and Challenger Deep, which is the deepest place in the ocean. It is deeper than Mount Everest is tall. So here's a little factoid graphic for you, but it is deeper. We've gone down in there in submersible tiny submarines, and it's incredibly deep. And that is just off the coast here of these islands, this volcanic arc. What's really cool about this is it's the Pacific plate interacting with, although there's a microplate here, we'll say it's interacting with the Philippine Sea plate. They're all moving in the same direction. So you can have convergence even though they're moving in the same direction. And some of you might be saying, what? But that's because the Pacific plate is moving so much faster than the Philippine Sea plate, much like you could crash into somebody on the highway if you are driving behind them, but faster. Okay, that is a type of convergence, but overall we still call it that type, ocean versus ocean convergence. Here we have the Alps of Europe, and the Alps were made a long time ago because of ancient plate tectonics. The Mediterranean is kind of a tectonic mess, but the Alps, okay, the main belt of the Alps here was made because of the African plate shoving other smaller continental pieces up into Eurasia before and after the time that Pangea started to break up. Okay, and that Mediterranean Sea was not always there. It was a lot of smaller seas, which had then have kind of closed up because of that continent-continent convergence. Pardon me, creating some folded mountains that we call the Alps. The next one, probably the most famous ridge in the world, Mid-Atlantic Ridge. The Red Sea is also on your list, but we just combine those two. They started out as rifts, much like the East African Rift, breaking apart Pangea. Divergence now in the ocean. They created the ocean floor that separates these continents, as you can see here, right? Just like we learned with continental drift theory. Ridge divergence in the oceans, okay? Next up, the Philippines. The Philippines are a very tectonically active place in the world. They actually have something called the Philippine Mobile Belt. You have all these tiny little microplates. You don't have to know them, but they're all being squished and shifted, okay, between two converging plates. So you have a tremendous amount of volcanoes and earthquakes. It's primarily the Philippine Sea plate subducting underneath the Eurasian plate, which is primarily, even though it looks like ocean and islands out here, this is a lot of old continental crust that's just jumbled and smushed together, even though they are islands. So sometimes things aren't always what you think they are. All right, Japan, the main islands, because there's a whole bunch of islands that go down towards the south that have a little bit different story. But the main islands are ocean versus continent convergence. It's an island arc. However, that's continental crust. When you see islands that big, they're not usually oceanic crust. They are usually continental crust that has broken away from the main continent. So here we have the Pacific plate subducting underneath the Eurasian plate for this part of Japan. And then here we have the Philippine Sea plate subducting underneath the Eurasian plate, giving us ocean-continent convergence. All right. You can see it's a complex area where you can have multiple plates, um, some subducting others, while another one is subducting underneath it. So pretty cool place, very earthquake prone, and some really big volcanoes. You might have heard of Mount Fuji is in that region of the world. Iceland, okay? The island that is actually more green than Greenland, because Greenland's covered by ice. That really makes sense, doesn't it? Oh, Iceland sits on the mid-Atlantic ridge. It runs right through it. Okay, so you have a huge amount of rifting going throughout Iceland with volcanoes, earthquakes, and there is a very famous hot spot, which we'll study when we study volcanoes later on, an interesting way to get volcanoes not at a plate boundary. That one happens to be on a plate boundary as well, so that's why it's super volcanic. Okay, next up, the Caucasus. Okay, the Caucasus Mountains is continent versus continent convergence. We have the Arabian tectonic plate, which is converging continental crust with the Eurasian plate. Okay, Arabian against the Eurasian plate, and that's continental crust, giving you folded mountains, which run into two areas that we're going to talk about in just a little bit. The San Andreas Fault we talked about in class, the Pacific plate, right? This very small amount of continental crust in the Pacific plate is scraping across to the northwest across the North American plate. That's a transform boundary. Pretty much earthquakes and faults only created there. And then we have the Zagros Mountains, so just a little bit to the south of the Caucasus, down into Iran, however you want to say it. Continent versus continent convergence, giving us folded mountains. Okay, also very earthquake-prone region of the world. Here we have another famous transform boundary, the North Anatolian Fault. And this symbol always tells us that there's a type of transform fault there. And that is happening because the Arabian plate is pushing on the Anatolian plate from the south, while the Eurasian plate is pushing from the north-northwest. And this rock needs to shift in order to make up for that stress and force. A transform boundary, making up the Anatolian plate, a very large part of, or most of, Turkey, the country. Sumatra, Indonesia, another very, very active place for volcanoes and earthquakes. You have the Sumatra or Java Trench right off the coast. That's actually continental crust, although it looks like islands and peninsulas there. The Sunda Shelf is a microplate of the Eurasian plate, and it is old continental crust. So it actually gets considered an active continental margin. Ocean versus continent. Indo-Australian subducts below the Eurasian plate. And that's it. That's all 21 of our locations for the Geo Tour. If you have any questions, please come to office hours or ask questions in class. I hope you filled this out. I hope you sped me up to 1.5 so this wasn't too long. Many of these locations are possible choices for your PT feature project, so maybe do consider that. You might have already been given some background information about them. Okay, I hope you enjoyed the tour. Get out there and explore the world when and if you can, and have a great day.